That's
good math there.
That's good math. That's the math you want to have.
Yep.
Welcome to Inside the Build, a podcast series that dives deep into how Forj Medical solves complex manufacturing challenges, told by the people whose knowledge, expertise, and ingenuity make Forj Medical the partner medtech companies trust when the technology is complex and the stakes are high.
My name's Troy Krigo. The job title is I'm the Senior Automation and Robotics Engineer.
I'm Adam Kress. I'm a automation and robotics engineer.
I'm David Franklin. I'm a senior product development engineer. So what we had originally for our manual loading process with our 8-cavity system included our molding press, which has that round table with 4 stations. This table rotates. Each one of these stations has one mold base containing 8 cavities per part. And what needs to happen is a needle needs to be placed in one of these cavities before the press could finish its cycle time. Based on trying to beat that, we had to put an operator at 2 different stations. Their job was to put 4 needles each to beat that press. At their little station, they get a tray of needles that has a little nest that keeps the needle orientated, so they have a better time picking it up. The thing that makes that tricky is the needle has this little hole in it that needs to align with this alignment pin, and it's only like a 10 thou clearance. So sitting there and just doing that with your hands or just imagining it, it's a lot of precision that a person needs to do and sit there and repeat.
And the needle has to face a certain direction because it's a needle that is basically U-shaped.
Yeah.
And they're wearing gloves.
Yep.
So it's hard to feel that detail of that U-shape and still get it on the post. Am I correct?
Yeah, and even with the naked eye, looking at that U-shape, it's hard to look at the part without a scope and know, do I have this in the right orientation? Right. They're kind of hoping that the needles that were in the tray that are supposed to be in the right orientation come in that orientation.
Yeah, and we know that the trays get bumped, and sometimes needles are not in the correct orientation when they're presented all the time. And then we got, was it a 22 or 25 second cycle time? They got to load 4 needles?
Yeah, and that's what we're always trying to beat, and most of the time we were longer than that.
Yeah.
The kind of, with bumping the needles, we'd have stuff where that whole tray, a little knock, and you'd have needles everywhere, needle points going everywhere, and they would have to take time to get everything back in place so they don't risk poking themselves.
Right.
There's a safety issue at this point, too.
And the tips are pretty sensitive, right, in terms of damage. And
the holes are sensitive. You can't bend the holes. You can't damage the tips. Mm-hmm. And let's just face it. I mean, an operator loading 4 needles over an 8-hour shift, they're going to slow down. They're going to get tired.
Absolutely. Yeah, then with that, like the needle itself, the kind of, with the size it has, it's only like an inch long. And like with the stamp seal, it's only 3 thou thick, 3 thousandths of an inch. So kind of what you were saying, we had several times where operators just putting it in the mold, they would bend it.
Yeah.
And then that would create a part that can't be used.
The flag. So it's a needle with like a square flag on the end that has the hole in it that's got to go on the post. And that flag would tip, and then when we went to the next station for vision inspection before we molded that needle to make sure that we keep our molds safe, then you'd have a different reflection in the camera.
Yeah.
And it happened pretty consistently where as operators get tired, that would be bent because they're literally kind of,
it's much easier to
they're not doing this with it. They're kind of laying it in.
Yeah, it's natural to put a little
natural, to lay it onto that post, which
such a small, delicate needle is.
That flag is very malleable, bendable, so it's easy to manipulate that while placing.
Yeah, and then along with kind of just how small and everything is, it was easy for them to sometimes miss that pilot hole, and the head would just kind of rest next to the pin, or the needle would be kind of off on an angle a little bit. And if we were ever to mold a part like that, that's a junk part right there. Yep. But that could also damage the tool that we're using.
Yeah, that damages the tool, and as we know, tool repair takes a significant amount of time. We're talking at least a half a shift to a shift. Roughly. Yes. And when you're molding 8 parts in 22 to 25 seconds, a full 8-hour shift, it adds up.
That's a lot of parts that's coming off. Yeah, and then if we damage the mold and cause some flash issues, and that gets caught a little later, then we might have a sort on our hands.
Correct.
And we have to even more time lost having people work through that instead of molding parts.
Yep. Definitely. So we can see why segueing into an automation assembly where you have repeatability, you have identification of that needle, you don't have the volume loss of an operator getting tired
Yeah.
or making a mistake, unfortunately. But robots don't get tired.
Yeah.
They don't care.
And with that like inconsistent cycle time, we'd have shifts where we had operators that they were rock stars and they would keep up with the mold, and then other ones that it'd be a little more hit and miss on the speed. So even just kind of relying on a consistent cycle time for planning and forecasting, it made it more difficult, and you had to include more variation when you're doing those numbers.
Yep. It made it much more advantageous for us to move towards automation to just keep that cycle time and the production numbers up.
Yeah, and the consistency, instead of relying on trained operators to do it, you can just rely on a robot that
A trained robot.
Yeah.
knows how to do it and does it the same every time.
Yeah, and these are all problems just with 8 cavities within 22 to 25 second cycle, and then we opened it up to 16 cavities,
Yep.
and that was just going to be
Yeah, there's no
needed.
way 2 operators can load 16 cavities in 22 to 25 seconds.
Right.
I mean, I would love to see it. Don't get me wrong. If you can give us 2 operators that do that,
Yep.
that would be really interesting to see, but there's just no way that they can do that.
No.
Yep, no way.
So even the fastest ones, it's
Yeah. I mean, I think we did, just for qualification wise, I think we had operators loading 16 cavities and it was way over cycle time.
Yeah, it was tedious, and
And
Yeah,
they were not happy, and we want to keep our operators happy the best we can. So yeah, moving towards an automated cell, which we have now, definitely was the correct move.
yeah, definitely needed for this one.
Yeah, definitely
Absolutely.
needed for this one. So we kind of thought outside the box when we did that, because we're working with a 4-station, 150-ton vertical press with a 42-inch diameter rotary table. And it's the Super Track was a new product at the time.
Yep.
And we thought, well, this is really cool. I mean, we can go forwards, we can go backwards, we can do whatever we want. We're not restricted to one direction rotary table. So and the maintenance aspect of it as well.
Yep.
I mean, it's a magnetic conveying system.
Yeah, it's very unique.
It's very unique.
Operation to
It's
move stuff.
very cool to watch.
It is.
It has so much flexibility, and we're only using a fraction of that flexibility.
Yep. It's capable of a lot of dynamic motion
Yeah.
tied together and stuff. But yeah,
It's an amazing product. And we thought, well, we have we can maybe move robots wherever we need to try to keep minimized floor space. Because let's face it, floor space costs money.
Yep.
certainly.
Whatever floor space that you're using, it has a value assigned to it. So you try to keep it as compact as you can. So what we did was take 2 robots that do tray handling. So we actually load the trays into a rack, 2 separate racks. And we have 2 robots that are just holding trays, and 2 robots that are picking from said trays, using vision to find the needles appropriately.
To find the needles and then also determine if they are flipped properly, because the needles are very delicate, and as you load those trays into the magazine, they can be bumped, and some of them can flip upside down.
Yep.
So
Agreed. And we have to find the hole, of course.
Yep, you certainly have to find the hole and make sure you're picking it in the right spot.
And unfortunately for us, the needles are brought to us in the wrong direction.
Yes.
Yeah.
They're
certainly
180 degrees long.
situation.
They're basically flipped upside down when they're brought to us. So we have to flip them over. So we pick them out of our trays, and then we present them 4 at a time. Well, we pick them each individually, place 4 of them onto a rotary flip station with some Z up and down flexibility to put them onto the platters of 4 and 4. So there's actually 8 on each carousel, so to say.
Yep. Yeah. Yep. In groups of 4, because that's how they are.
That's how
Each
they're
section of the mold is
section of the mold is
broken into
basically
4,
4,
needles.
4, and 4 for 16.
Yep.
So we place them onto the platters. Then the correct orientation and then we stage multiple platters.
Yep. Essentially build up some width.
Inventory.
Yep.
Yep.
To account for when you got to change tray over and things of that sort.
Exactly. And then we have another robot that picks up those 4 needles and places them accordingly into the 16 cavity mold in groups of 4. So 4 needles in 4 quadrants. And then we do some vision inspection to make sure that we've placed all 4 needles onto that mold according to the robots to make sure we didn't leave any behind. And we keep doing that within 25 seconds. Is that one?
Currently, we're at like 18.
Yeah, so
seconds.
that was I was just thinking that. So when we went to 16, so we had to double the amount of needles we did.
Yeah.
But with how the design of the mold changed, we made the cycle time faster. So you guys had to double the amount of needles you put, but we also moved the goalpost in, so you guys had to do all of it in less time.
Yeah. So we went from an 8 cavity mold, which was 22, 25 with the operator.
On a good day, yeah.
On a good day, had a very good day. Not on a Monday.
Not on a Monday.
Not on a Monday. To 18 seconds for 16.
Yep.
I mean, who doesn't love that one? That's great.
Good math there.
That's good math. That's the math you want to have.
Yep.
And very reliably, we have 2 systems running, one running a 16, one running an 8, but they're virtually identical. The other 8 can run a 16 if we so desired.
Yeah. It's basically the end product that's slightly different. It's just the features of the mold. The operation of the system's identical.
Yeah.
Then we do a little vision inspection to make sure we don't damage our mold.
Yep.
Mold our parts in an 18-second cycle, and then we offload to another tray, which is basically an offload system that again has a rack of empty trays and a rack of full trays, and we just grab them out of the mold and put them in the trays, and away we go.
Yep.
And when we have a full tray, we put the tray away, and the operator then removes said full tray for inspection.
Yeah. They do a quick check, and then those parts are pretty much ready to be packaged and out the door.
Yep. And they package them. They vacuum. I think they vacuum shrink those.
They do in stacks of, I believe, 5 trays.
Yep.
Yeah.
Yep. Right at the press there.
So a very cool little automated cell to watch.
It is. And there's definitely some unique challenges with handling those small needles and determining, do we pick mechanically versus vacuum and stuff like that. It was definitely some trial and error on the development side.
There are some learning opportunities.
There's certainly some learning opportunities. There's still things we work to improve on that system.
Yeah.
Adding additional vacuum holes on the nests so that when we flip them so they don't want to slide. Some nuances with stuff like that, and some more nuances with the vision side of things.
And let's face it, there's some wear in there that we didn't anticipate as
Yeah.
well.
Yep.
I mean, those needles, we found that, even though we place them very accurately, they wear the nests a little bit.
Yep. Yeah, and I think both machines are at about 10 million-ish cycles. So
We didn't anticipate that. I mean, we figured there'd be wear, but
yeah.
And some good little trial and error and different material types for those wear items or just coatings and stuff like that. But we've made some good improvements.
yeah, very good improvements.
Run smoother.
I think with being able to increase capacity and keep up with cycle time, I think the Super Track was definitely a huge component of that, being able to load up several pallets because each tray does only hold 200 needles, I believe. Yep. So the trays do need to be changed over. So while you're doing that, if you can build up some extra flipped needles in advance to accommodate for some of that time, was a big help in doing that, because the mold is capable of running like 18, and I think a tray change takes at least 18 to 25 seconds, somewhere in that ballpark.
And if we needed to, we could always add more carousels and whip.
Yep.
Yeah.
That's the advantage of that Super Track is.
Yep. You have the flexibility to add and remove as needed.
Exactly. And you can control the speed at which it comes around the corner once it's empty to get back into queue.
Yeah.
Because I think that's the key of that right there, because all those little pallets that we have on that, they're all independent of each other. So they're not waiting for another step to be done. They can, if they're ready to move, they can move to their position.
Yeah, they are not tied to each other whatsoever. They don't move in synchronicity of each other. They're all independent thinkers, so to say.
Yep.
When we want it to move, it moves. And it moves as quickly or as slowly as we need to make our cycle time.
Yeah.
So that's huge as well.
Yeah, I was going to say another thing with that too, the ability to adjust speeds and stuff. An unforeseen event when we're going around the corners and you're carrying those little needles on tiny pins is you actually have to go pretty slow as to not throw them off the track.
Yeah, there was not much locating them once they're on that pin.
No.
There was no detail to hold them in. It's not like you can tie a vacuum to that super track to make sure they're secure. You're unfortunately relying on gravity.
Yeah.
Which sometimes gravity is reliable, sometimes it's not.
This is very true.
So
I think another key factor too when talking about speed and cycle time was optimizing the robots using simulation software to make sure that you're picking within optimal envelope where the tray can be moved around and the top one can reach all the positions, but also in a spot which is very optimal in terms of speeds to make a quick back and forth on no matter which
station.
Yeah, which spot on the flip station is replacing. Because sometimes that is not necessarily taken into account. If you're working with a huge tray or something like that, and when you're doing the close moves, it can be really quick. And as you go further and further, you stretch that cycle time out.
Depends on the joint combination of that robot.
Exactly.
I mean, some joints move faster than others.
Yep.
We know that.
Yeah.
So that's where simulation comes in handy to get those faster joint movements where we need to.
Yep.
Yeah. Very, very good point.
Yeah. Another one that I think is really important for the overall kind of effectiveness of that machine is right up front with picking those needles and all the cameras we have to make sure that they're in the right orientation and we can grab a good needle and know it's good. Because anything that's left in that tray just gets dumped, and that's another form of scrap right there that might go unrealized.
Yeah.
So how many cameras do we have with the tray with like the backlighting?
So there's 2 cameras looking at each tray. 2 cameras? 1 camera, sorry. There's 1 camera looking at each tray.
Yeah.
Initially
the other one's a light.
Yeah, there's 2 different lights.
There's
There's
a backlight.
Does 2 different processes. One, it uses a side light kind of top front side light. To hit the 2 kind of top posts in that U channel to create 2 lines. And if it doesn't see that, it knows that it's in the improper orientation for what it's looking for. And then it takes a second image to find the location, which is a backlit image, which finds up, down, left, right, twist orientation so that it can pick it properly. So 1 camera, 2 different operations, snaps a set of 5 to check a group of them for orientation, and then for position, it snaps singular pictures.
And just for conversation's sake, what's the size of that tray? Does anybody remember?
Oh, I want to say it's like...
It's not a small tray.
No, I want to say it's like 6 or 7 by like 20-ish.
Yeah. It's quite a big thing to backlight.
Yeah.
Yep.
So I know there was some creativity there to
it was a
backlight.
Unique challenge of looking at what was available on the market for buying a purchase backlight, because sometimes that can give you better reliability. It's easier to change something out if it's just a purchase component, but that doesn't always lend itself to custom unique solutions when you're trying to pick these trays also. So we ended up having to make our own backlight with strip LEDs and a Delrin top to that picking end of arm to give you proper backlit light dispersion and stuff like that throughout the tray. So there's not dark spots or hot spots.
Exactly. Yep.
So there was a fair amount. I think that was the 8th or 9th revision of that end of arm by the time we got it all said and done. There's another very unique challenge where too good of a seal on the tray itself actually, because it's a thermoform tray, would suck it down and actually like distort certain spots of that.
Yeah.
So it was kind of a unique balance of you want some leak as to not create a perfect seal on it, but enough suction to like kind of pull it down and be uniform.
And I don't think that's something we mentioned. We're actually holding that tray with vacuum.
Yes.
We're picking the needles with vacuum. We're holding the tray with vacuum.
Yep.
I mean,
yeah, tray kind of rests. It's located on there,
but on there.
But the vacuum helps kind of flatten it out,
tray out,
get rid of any inconsistencies.
Right, thermoform tray. It's gonna have the wave effect to it a little bit. And every tray is not the same.
No two
So
trays
we
are
used
gonna be
vacuum to make sure it's nice and flat, to make sure we have a really good pick.
Right. Yep.
And so it's not springy. And if it was springy, what would happen after we picked?
Bouncing the needles.
We'd be bouncing the needles all over the place. And now we're throwing away 150 needles.
Yep. That is exactly what happens with that tray, because when they're warped, they get launched down, you hit it, springs just kind of like when the operators are doing it manually and stuff, hence probably why you guys had the 8 or 9 revisions of that
Yep.
to get that working smooth now.
Yeah.
Yeah. The question is, what would we do again?
Mm-hmm.
Yeah.
You know, if we had the blank slate to do this all over again, what would we keep? What would we make better? What ideas do you guys have?
I mean, I think the Super Track is a
Yeah.
great piece of technology just in terms of giving you flexibility in how you want to program stuff, how you want to group needles, how you want to move them around. Just gives you so much flexibility in the process that I think that would be something that I would definitely want to use again.
Yeah.
And it allows you to kind of create that break in our kind of whole, if you were to think of it as assembly line, you have breaks where some processes can take longer without slowing down other things down further in the line.
Right.
Yep.
You have the flexibility where you're not linked to every single pallet. You have the flexibility to move everything individually as slow or as fast as you need to.
Nope.
Or to expand.
Yes.
Because that track is expandable in way more things than we've ever been touched.
Yeah. Yeah. You could certainly add segments to it.
Yeah.
And
Instead
add
of
other
just
processes.
for us, we move in basically an oval racetrack.
Yep.
You could offshoot off of that. There's a way that you can offshoot to a different process if you needed to, and then come back into the queue if you needed to. So if you had a problem, you have the opportunity to go fix that problem and run back into the queue again.
Yeah.
So
Yep.
there's a lot more. We scratched the surface of what that thing can do. I think there's way more.
Yeah, there's way more options you can do, and you can drive pallets in both directions. You
Yep.
can do all sorts of stuff. You can go backwards, and yeah,
Lots of very cool.
and endless possibilities basically with
Right.
something like that. So
So that's one thing that we would keep.
yeah,
I think the robots are also
Yep.
another thing that we would keep. We use Epson robots, which have been fantastic
Yeah.
in their support
and reliability from a product standpoint itself.
and repeatability.
Yeah,
They're very repeatable.
Yeah,
And they're very
yeah. Specifically, those scare robots are super amazing for that's all they do. They
Almost
just go and pick
bulletproof.
the needles, and that's all they do, and
Yep.
they work just great.
and they do it
Very
well.
low maintenance on them.
Another thing that we've done, and most people think of robots as I use the end of the end effector.
Yep.
We actually use the top of the robot.
Yeah. Yeah, it is unique in how we're doing that.
We use it exactly opposite of what most people think a robot is for. We use the top of the quill
Yep.
to handle trays, and we do that on-load and offload,
Yep.
not just one.
Yeah, they're hiding down
Yeah,
deep in the machine.
exactly. They're buried in the machine, almost like a hidden hand that's just kind of cruising around grabbing trays.
Which again gives you great flexibility with grabbing trays and being able to grab out of either rack with either robot to allow operators.
And I think
to,
they can cross,
yes.
if I remember as well.
Yep.
I think we designed it so we can go from either stack of trays, and if one isn't full or is being changed over, the robot can go over to the other side and retrieve a tray from that side as well. So that's definitely another thing that we would keep.
Yep.
Because that flexibility is huge as well.
Yeah, and it just leaves less time, less interaction with the operator. They don't need to be managing 2 racks at the same time. They can comfortably go into one while the other one's being worked out of both robots.
And safely.
And safe.
Yes.
So you can do it
They're
they're all
guarded with
interlocked.
light curtains and door interlocks. So
And the robot can't go in if the door is open.
yes. Yep. And if it does try to, it would break the light curtain and stop.
Exactly.
These robots move slow.
So very safe
Yes.
process there. One thing that we should talk about is, what would we change? What would we make better?
Certainly. I think there's a handful of stuff we're working on, still refining and still learning all the nuances of handling small needles and lot variation and stuff like that. I think the flip station nests is an area that could certainly be refined more. How do you hold a little needle in place as you load the other 8 and then flip them over and set them onto something else extremely accurately?
Because we're holding on needles with the flip station with vacuum.
Yes.
So we place them on there, we hold them with vacuum while we flip, and then we actually reverse that and blow a little bit of air to
Try to let them let go.
move them off of that nest, because they do stick a little bit.
Yep.
You don't think they will, but then again, gravity goes back into play again. You can't always rely on it.
No.
So we give it a little bit of an assist, poof them off, or a little bit of air blow at a very low volume to just put them onto that.
Yeah.
Yeah. And then that's a
Ladder.
completely blind handoff, right? There's no like mechanical interface to make sure everything's aligned. It's just
It's
trusting the
pure alignment.
comes down to the right point and that the super track came right where it's supposed to be.
Yeah, that all the servo motors involved are all where they're supposed to be.
Yep. There's a lot of accuracy there and a lot of setup for technicians.
Yeah, which is, when it's all working, works very well. But there is a lot of stuff that has to be set up exactly right in order to lead to that. And then any little variance or issues, sometimes you'll see the needles will flutter a little when they're sitting there on the nest and stuff like that. Lot variation, how they're formed, because they're not flat on the bottom. It's more of a curved surface. So you're not so much sealing as just pulling air past them, which sometimes makes them flutter. So yeah, there's definitely some improvements and things that could be done there.
I know the one thing I would change if I could. If I had like any option to change whatever I wanted to and we had customer buy off,
Yeah.
I would change how we get the needles.
Oh,
yeah.
I mean, if you didn't have to flip them,
We didn't have
we'd
to
have to
flip
flip
them.
them.
If we could just pick them the correct orientation, that would be the number one thing. And that's 15 years ago, I think, that we started working with these needles roughly. And I think if we had a little bit more forethought into, hey, we're going to automate this 10, 15 years from now to do this scale of automation, that would have been like number one. So that forethought of working with our customer to get a good package for future automation would be critical.
And that kind of shows one of the challenges that you guys were able to come with it. Because for a human to take that needle and be like, oh yeah, I just need to quickly turn my wrist to put this in the mold, that's way more complicated to get robots to do that amongst talking to each other.
Right.
We were able to do that.
Yep.
Exactly.
One I have for is when we only see the needles when we first pick them with a camera, and the next time they're seen by a camera is on the press. And we've had times where needles are misplaced or maybe a little damage on the pinhole.
Yep.
And I think if we could have a camera system over the pallets as they're waiting to go, it just this one's good, this one's not, and then something to indicate it so someone could go in there, get rid of the bad ones, and let the machine keep going. And we don't have any bad needles make it into the mold.
Or even an automated way to pull the needles
That's
off the pallet if they are no good, or pull small sections of them off.
Yeah, you could have another robot, which is an individual, like a small robot that just handles an individual needle that could just pick it off the pallet and replace it as it's waiting in queue, because we have some time.
Yeah.
Not a lot of time.
And you could just not load whatever ones are already there for that one. We know which pallets are which, and we know what's on them.
Exactly. So. I mean, you could even... you can do that. You could probably even bypass the flip station and just replace the one after the fact.
Yeah.
And just run it all the way back around, because we have the flexibility to do that with the super track.
Yeah. Yep. So the super track and the robot's loading, you can load whichever locations you'd like.
Yeah, that would be handy.
This has been Inside the Build, podcast series by Forj Medical, where we're shaping the future of life-saving devices, one build at a time. Thank you for listening. For more information, visit us at forjmedical.com.